the password game. In this game, the main goal is making a password. Simple, right? Wrong. Because you have to make your password which satisfy all conditions of the game. These conditions can be as simple as your password must be at least 5 characters, or they can be so stupid like solving a chess puzzle to move on to the next rule, or playing geoguessr, or playing Wordle. Like, why do we need to play Wordle on a password making game? Anyway, because it is such an amazing game, I decided to make it in Minecraft using redstone. And it's a really bad recreation because my brain is way too small to make it better. However, I will still gonna try to explain everything about the game because I think it's really interesting, and maybe after this video you can make your own, hopefully. Okay, before we get into the redstone, we first need to understand how does the password game work. Well, let's look at the game and analyze it. So the game has a lot of features. It has a place for us to see our password. It has rules that our password must satisfy. It has check to see whether our password satisfy all the rules or not. And it has a winning notification when you win. But the two most important things that we need to solve in order to make the password game is understanding how the game works at the most basic level, and how to make this thing right here, like this bar, like this area where you type in the words. So first thing, we need to understand how the game works and how to win it. To win the game, the password that you make needs to satisfy all of the conditions of the game. And when I hear that, my brain instantly pops up this image right here. This is an AND gate. These are its inputs and this is its output. An AND gate will only give out an output when all of its inputs are on. This is the same as the password game. We only get the W when our password satisfies all conditions. So the conditions are inputs and the W is the output. So in a nutshell, the password game is just a really thick AND gate with more than 2 inputs. The next thing we need to solve is how to make the place where you type in your password in Minecraft. To do this, I need something called a word processor. A word processor allows us to do basically Microsoft stuff like typing, backspace, space, etc. This part of the project I think is the most complicated part, and I had to spend a lot of hours on it. So we have a thick AND gate and a word processor. If we combine these things together, we will get the password game, just a super bare bone version of it. So now we have understand how the games works and how to make it. We can start making it in Minecraft. And now I will explain all of the redstone stuff. Let's start here at my epic gaming keyboard. This keyboard has RGB lighting, mechanical buttons, and the color theme of this keyboard is brown because brown is cool. Now, as you can see, the keyboard has 36 characters minus the backspace, the delete, and the space buttons. This means that I need 36 separate lines for each button. But if we follow the brown lines, we can see that there's only 6 lines coming out of the keyboard. In order to transmit 36 different signals using only 6 lines, I use an action called encoding. So what is encoding exactly? Well, encoding is an action which turns information into code form. For example, I have here a number 6. I can encode this number, which is in decimal, to 0110 in binary. The 0110 is a representation of number 6 in binary, or a code associated with number 6. Now, if we do this to all characters, we can transfer different signals using the same redstone lines. If you want to understand more about this, Mattbatwings has a really amazing video about the topic, and I will link it in the description. He explains much better than I could ever have done, okay? So we have every unique 6-digit codes for each button signal. Great. Now what? Now we transfer these signals into our word processor, which is this whole giant thing right here. Because there are a lot of showcasing videos of a word processor, but not a lot of explanation videos on YouTube as far as I know, I will try to explain how to make a word processor to the best I can. Now, we need to understand the main goal of a word processor. The main goal of it is basically to be Microsoft Word, just a very nerfed down version of it. So let's build one from scratch. First, I will make a screen. So this is a screen, but it's actually not a screen. This is what like you see in front, but this is what behind the curtain. As you can see here, the screen is actually multiple screens stacked next to each other, and we can control these screens to output the characters that we want. But how can we tell the screens to display what we want? Well, to do that, first we need to store all the characters in the word processor. So when we want to display a character, we can just find that character in our storage. In order to do this, we need to use a ROM, or read-only memory, which is this gray and light gray block of redstone right here. A ROM, or read-only memory, is a type of non-violate memory. Data stored in ROM cannot be changed. So to understand this, simply it's like a chest which we can take out items, but cannot put new items or change the items or delete the items containing in the chest. We use ROM to store all 36 characters on our keyboard. So when we press a button on the keyboard, the ROM will tell the screen what character it needs to write. However, we aren't working with one screen. We are working with a lot of screens. If we put all of the screens together, each of them with a ROM containing all 36 characters, the word processor will be huge and slow as well. So instead of doing that route, I decided to use only one ROM and hook that ROM into every single screen. So now, when we select a character in our ROM, all of the screens will display that character. However, when we don't select that character anymore, all of the screens will be off, which is not what we want, because we want to see stuff on the screen, right? To solve this problem, I added memory circuits to all the screen, which is this orange part right here. The memory circuits will remember the character we input. So when we don't select the character anymore in the ROM, the screen will still remember and display that character. But the next problem arises is all of the screens lights up every time we select a character. To solve this, I add something called a lock to every screen. Well, that's what I call a lock. I think in like computer science is something else, but I don't know. So if you know, you can tell me in the comments. So how does this lock work? Well, when we select a character in ROM, nothing happens on all of the screens because the locks have blocked the information from ROM to the screens. However, when we unlock a lock, the corresponding screen will light up with that character. If we do this with another lock, the same thing happens. This is how we display different characters on different screens using only one ROM. Unfortunately, another problem appears, and it is how to control these locks automatically, because doing it manually is kinda dumb. To do that, I used a shift register. A shift register is a circuit which, as the name suggests, shift the data from one place to another. In our case, the data we are storing inside of the shift register is unlocking lock. We connect the shift register to all of our locks, so when we shift this data will reach different lock and unlock it. The final problem is backspace and delete function of the keyboard. First, I will tackle the delete function because it's easier to explain. The delete function just basically clear everything. Like it clears all of the memory circuits back to their default state and reset the data in the shift register back to its original position. The backspace function is slightly more complicated. It's similar to the delete function, where it will try to clear every memory circuit. But unlike the delete functions, the backspace function is blocked by the locks and will only be able to delete memory from screen which lock is unlocked. The backspace function also tells the shift register to shift the data back from the current lock, which is unlocked, to the previous lock. And believe it or not, that's the entire word processor that I made. Now the word processor is complete, we can move on to the actual password game, which is this stretch circuit and this cyan circuit right here. The stretch circuit, yeah, I call it like that. The stretch circuit is a giant RAM hooked up to multiple decoders, and the cyan circuit is basically just a super thick AND gate. So what is RAM though? Well, RAM is a ROM, but we can change the data on it. But why do we need it? Well, we need it because we want the game to remember all of the characters that we have pressed, but also clear each memory cell every time we press the backspace button. And the thick AND gate just tell the player when they choose all the correct characters which have been set up before. And yeah, that's all of the essential parts of the game. All the other stuff that I add are just for cosmetics, such as these lamps right here, or the text above there, which change every time the player is closer to the end of the game, or this cursor, which is controlled by this yellow circuit right here. Now, my password game is very broken. It has a lot of flaws. For example, the space button. The space button or the space bar does not work. Kind of, not really. It works, but you can't use it as a correct answer to in the actual code, like in the actual password that you make. And also the password that you make is very limited. It's not like in the game where you can have like a full word. Okay, yes, you can still make a full word, but it needs to be individually individually encoded, so individually chosen in the in the actual answer. You cannot just have a full word on a line, on like each line like this. You have to select this, this and this if you want to make a word, which is a flaw, I know, but I have no idea how to make it like similar like to the game. This is the best that I can do. That is why I try to explain this game as best as I can. So if you want to make it and make it better, you have all of the maybe resources for like all of the essential part that I have made. Maybe you like can learn from it and make it better. But yeah, my game works, but it has a lot of flaws. But yeah, and I don't know how to make it better. So go ahead and make it better if you can. So yeah, that's the end of this video. Hope you enjoyed the video and hope you have learned something from it. Thanks for watching and I will see you in the next video. Have a nice day everyone.